doing our part one of our two-part session on the evolution of the smart meter. Our second session will be on September 15th, same time, so 1 p.m. Eastern. We will send out invites to everyone joining today, so you'll get a reminder on that, and we do hope to see you there for the continuation of this segment. We'll keep this to a 30-minute session. If anyone has any questions, there is a chat at the bottom of the screen. Please feel free to post any questions you have. If we can't get them to them in the session, we will follow up with you and get you some answers. And we'll also post an email near the end of this session here that you can send any questions or follow-up information that you might like. And we'll be sure to respond to that. So now I'd like to introduce our guests. We've got Ross and Dave with us today. Ross is the inventor of the world's first and most successful radio frequency utility meter. He created the ERT, the original ERT that Itron currently uses in their drive-by meters. He has been a key driver in many regulatory changes, including restructuring state and federal regulations around the unbundling of metering and billing. And he's provided demand response services to many utilities around the world. And thank you, Ross, for joining us.
Welcome.
And we've got Dave Hyland with us as well. Dave has over 2 decades of practical strategy and operational experience in both regulated and unregulated energy companies. He specializes in smart grid strategies, demand response, and supply management. And thank you for joining us, Dave.
Hey, you're welcome. Thanks for having me.
Before we get into any kind of the technical details around meters and how they evolved, I'd like to just ask both of you, maybe we can start off, Dave, here. Why do we even need smart meters? What metering seems like it can be such a small part of the business. Why is it considered so important?
Well, yes, you're right. It is a small part of the business, but like any business, and when you say business, the most important thing to any business owner is being able to collect money or the cash register. If you have a Dairy Queen, the cash register is very important because at the end of the day, that's what pays for all the overhead and the people behind the counter. So that's the way the meter is the way that a utility actually makes money. And pays to keep their people employed and expand their services.
And I'm at some point really the system needs an upgrade, and so you gotta be able to have that reserve to be able to upgrade the system and keep up with technology changes in the rest of the world too.
Well, you're absolutely right. And along with that, people like accurate bills. You know, when you go to the grocery store, you get the receipt. They hand you a receipt. And if you're anybody like my mother used to be, she actually sat down and went through every line out of the receipt. So people like to know that they're getting billed accurately. And power, water, and gas are scarce resources, and we need to track it and utilize those to the best of our ability.
Yeah, it makes sense. Absolutely. Ross, can you tell us maybe a little bit about what metering technology originally looked like back in the day, and maybe some of the why some of the changes were needed around it?
Well, I wasn't around quite that long ago. The first meter patent was, I believe, by around 1872, and all the meters in those days, of course, were all analog. The technology between electricity, water, gas is very different, though. You know, if you think about an electricity meter, and some of the first ones, it was almost like a high precision instrument, almost like a watch that was running backwards. Whereas gas and water meters are what we call positive displacement devices, and over time they slow down, and utilities will lose revenue, and they lose accuracy, so they have to be either brought in and refurbished or replaced. Early on, I'll say most of the R&D that was going on with metering was really, trying to get costs down. I'll say cost and reliability. And the meters, utilities back in the day would probably depreciate these things for, 30 years, and many times they would have at least a 50-year life. And I don't know how many other devices or products you buy that you're gonna get that kind of kind of reliability in. One of the things that you need to understand is losses in the system. You know, for gas and water, gas in particular, losses, and meaning leaks, are pretty important because as you can see in some of the safety issues with some of the utilities, there was one that occurred down on the West Coast. It was pretty dramatic. Water was really the last of the three commodities to get metered. I remember back in the day when in New York City, water was hard charged. You know, you just paid a flat fee for as much as you wanted to use. Well, as water became more and more scarce, metering was needed in concert to promote conservation, and it's basically considered a public good. You know, the other thing that you have to keep track of is something utilities call non-technical losses. When to the layperson that means theft. So metering can help you determine what kind of losses you're having with all the three commodities: gas, water, and electricity. But as we started to get into in the late 1900s, more information was needed, particularly for electricity. So this electricity is this goofy thing. It's hard to store. We're seeing some energy storage now, but it's sort of expensive. So the time that you use electricity becomes extremely important in being able to measure that. And now with starting in the early 2000s, we've gone from these analog devices that you'll see on the like a 1948, the meters with the dials and the disc, to the solid state meters, which you see down the lower right.
Some pretty amazing changes around the metering technology over that period of time there. So we've got this. Well, go ahead, Dave. Yeah.
Until recently, electric really couldn't be really stored until the innovations with the lithium-ion batteries. There was no storage for electric. Gas could be stored in underground salt mines, and of course, water can be stored on lakes. But electric was make it and use it. And fortunately, now it's a different world, and we can store some electricity.
Absolutely. And then some of those other losses become more important too, to track that, how much is actually getting used and how much is getting lost. So impressive changes in some of the technology for the meter itself there. What about actually gathering that information? Because that, as the technology changes, the readings change. Dave, can you tell us a little bit about what that looked like in the early days, and maybe some of the issues around that contributed to needing some of these advancements in the metering?
Yeah, well, the early days, and you might know this from, well, you might not know this, but in the early days, in a lot of rural areas where meters were some type of distance apart, some utilities, like what you're seeing on the screen right now, actually sent a postcard to their customers, and then had their customers fill out, where the dial was on the meter, and then mail that back to the utility. So really, the meter read was done by the customer themselves. Since that time, you've got meter readers, and I remember even to this day, meter readers walking through your neighborhood, dogs barking at them, who knows what's going on, jumping over fences and getting a read off a meter, and then taking that back to the utility to put in the database and then do some billing. A lot of times, meter reads were missed, whether it's a fence issue, a dog issue, or even, I remember one time we did some metering for this gigantic house that was white in Washington, D.C. You couldn't just walk in and read that meter. You had to have special clearance. So there's always problems with meters being inaccessible to get to read those meters. And of course, reading the meters, since it's what the customer gets billed, it's important for the customer. Regulators don't like the idea of a utility doing estimates because it's not exact, and it always raises questions with the consumer. Itron started with the first hand read meter, and then from that point in time, we've evolved into AMR, and then of course nowadays AMI.
Yeah, quite the evolution there. Ross, do you want to give us some more details on some of how of that meter reading evolution? I mean, we're talking about the gathering the data here, but really a lot of that's connected in with the meter itself. So can you walk us through some of that
Sure.
process?
I remember back in the day, I was running marketing for the AMR division of the largest utility meter company in the world in gas, water, electricity. That happened to be Schlumberger. I remember one of our clients was Cincinnati Gas and Electric, and the meter reading department had 70,000 customer keys that they kept track of to be able to get access to these inaccessible meters. I mean, think about the liability of that today, right? So the early drivers for AMR were really inaccessible meters, meter reader safety, customer privacy issues, cost reductions, and getting more timely reading. The early AMR technology was actually predominantly in water. If you think about this, a residential water meter is usually either if you're south of the Mason-Dixon line in the United States, that meter is usually in a meter pit that usually fills up with water when it rains, or the meter's in a basement. Either way, they're fairly inaccessible. And then the gas industry was next after water, and electricity really was third. The first version of this, I don't know if you remember this, Dave, but with that Itron handheld device, they would have a little round thing that looked like a hockey puck that would be mounted on the side of the house with a wire going down to the meter in the basement, and you'd bring the handheld device over there and you touch it. It was actually called touch read. It was pretty interesting. The next step really was using telephony and cable to read meters. And it worked. There were some, it was kind of expensive because the install, you had to have a run of wire to the meter and then someplace outside of the house, and then connect either to the cable system or the telephony system. And there was actually two versions of the telephony based. One was a phone home version where the meter would call you, and there was a second one that was what we call an outbound telephone. But it was done in conjunction with the phone company. You'd put basically a box into the central office, and it would use the test trunk of the phone company to read those. Again, expensive, kind of clumsy to install, and we really need, the industry was crying for was really some kind of an RF solution that would make the install easier, and you wouldn't have to coordinate with third parties like cable companies or telephone companies. So that started out with putting a radio on a meter and then putting a transceiver into that handheld device that the meter reader was carrying around. So it was still what I call pedestrian telemetry. And then finally we went to a mobile device where you had increased range, and you could read maybe 20 or 30,000 meters a day per individual.
Wow, and that's really where you came in was on the drive-by radio frequency, where you can do that from a distance. Can you give us a little more detail on what that looked like and that process that you went through?
Yeah, I got a call from the chairman of the holding company, the gas utility in Minneapolis. A company's called Mini-Gasco, and they were having a dickens of a time trying to get meters read. In fact, they were getting I believe we're getting something like 5,000 written complaints a month on estimated bills. So decided to see if we could solve that problem, and it was a real customer service concern, and had all kinds of regulatory penalties, problems. But coming up with a solution that was going to work, it had to be, number one, it had to be reliable, and it had to have a life which approached the life of the meter. And if you think about that back then, this is like 1984, 85, 86. If you're trying to put a power supply on a gas meter, meaning a battery, what battery technology in those days was going to last 10 plus years. So that was probably the biggest technological problem that we had, was trying to figure out how to get a battery to survive 40 degree below zero winters, and 100-degree days and humidity and spiders and UV, all those kinds of issues. And we actually contracted with the implantable pacemaker company Medtronic to help us design that battery. You know, it was we had to get the RF out of the basements, and so you know, had to decide what frequency you're going to use. And we were lucky enough to be able to actually acquire a land mobile radio company in Minnesota that had the expertise on the RF side. And you know, back then when we actually demonstrated that system the first time, you know, people thought it was smoke and mirrors, but it worked. And you know, we certainly had our issues during the startup phase of things we had to learn the hard way. But you know, getting the RF out of basements and pits was difficult, but we solved that problem, and we were able to get the manufacturing costs down, and that technology more or less became the standard of the industry for probably 25 years, and just now is beginning to be replaced.
We've got a question here, actually, just what you've mentioned there, asking about, is the meter powered by battery or drawing power from the grid? So
in the case of the electricity meter, it's drawing power from the grid. In the case of the water meter and the gas meter, it's a battery power supply. And if you're interested in that, I'd be happy to maybe talk to you offline about that, because there's a whole discussion about battery power budget and how do you make a battery survive when you're blasting all this RF out, which wants to tear the battery apart.
Yeah, absolutely. So that's one major input on the business case for smart meters, is where your power comes from.
Yeah, but you're also looking at transmit times, and if you're transmitting the meter readings all the time, that battery's going to just die quick.
Yeah.
So you've actually got to have it be smart, or be able to wake that meter up to say, okay, send me a read, instead of always on like a radio or whatever.
Right.
Batteries don't last forever.
Yeah, absolutely. So we've heard you guys say that as an input for the business case. I've also heard you mention a couple times that complaints are a big motivator, or I guess avoiding complaints are a big motivator for utilities. Dave, can you explain that a little bit more? What are the issues around that, and why can't we just have some complaints?
Well, like anything else that's in the public venue, people complaining get a lot of attention. And utilities are basically a franchise that is given to an organization or a company to do a particular service, so supply electric or supply gas or water, and it's basically a monopoly where the utility is the only one there, and there's no competition. So of course, at some point in time, if you don't treat your customers well, or they start complaining, somebody that has handed that company the exclusive franchise for that service area, they're going to get a little upset. So you don't want to upset the commissions, because that's the last thing you want, because when you've got to come back for rate cases, you don't want that held against you, number one. And then also with the turn and the environment on consumerism, you also have companies like J.D. Power, which rank utilities as far as customer satisfaction. Those rankings are very important to electric utilities, especially, and gas utilities. So that's why you'll see in those utility type of operations, you'll see a lot of PR people. So if there's a gas company that has a gas line blow up, you'll see a lot of meetings with the press and the governor and whoever are people of importance, and the stakeholders. So it's an important thing not to have any complaints. And of course, if your meter reading isn't accurate and your bill's not correct, that's the first thing that's going to happen, is you're going to get a complaint. So you want to stay away from that.
Right. And so we've got a push for developing this new smart metering technology, but I can imagine there's also an against side. Ross, can you share some of the againsts that are again for this change?
Yeah, I mean, looking back in those days, I mean, there was a ton of reasons why we should have failed, and we should have failed. We should not have succeeded, because we were pushing the boundary on a lot of the product development side. But technology aside, some of the things we had to overcome. One was, the device has to get mounted, has to get installed on the meter, either in the field or ideally on new meters at the manufacturer, to help get your cost down. And we had, we were like, gnats they wanted to swat away, because the meter companies had, decades long relationships with their customers, and the last thing they wanted to have was some little upstart, company that want to put this appendage on its meter, and disrupt that relationship. And that was a real problem for quite a while. And it was until we sold the first two systems where I could say we had customer market power, where if the manufacturers didn't work with us, they were going to stop selling meters. And if you're introducing a product in the utility industry and you're coming up against an incumbent, it is just critical that you get customer buy-in on this to be able to get so you can change the leverage on the relationship. Some of the other pushbacks, utility folks, a lot of them are my friends, but they're not usually rewarded for taking a lot of risks. And this was sort of considered to be kind of risky, because we're going to put the utilities, we're going to spend, maybe tens or even hundreds of thousands of dollars, millions of dollars on these devices, and they better darn well work, and they better darn well have a lifespan that met the business case. We also had a fair amount of pushback with the union. I remember when we started to introduce this, and there was an organization called the Remote Meter Reading Association. It was a bunch of meter reading superintendents, and I wanted to go to their conference and introduce this product, and they gave me the bums rush out the door. So we had to actually go start our own association called the Automatic Meter Reading Association, which eventually put the other guys out of business. So the regulators also had to be convinced. I mean, they're not usually known for taking a lot of risks, but we did a lot of pilots and demonstrations that this would work. We had to go in order for the business case to work in these things. You weren't just going to be able to replace the meter readers and the uniforms and the insurance. You actually had to go in and sort of do a study on the utility and say, if we had 100% timely, accurate data, how much cost can we take out of the utility? How much cost can we take? If we're eliminating customer complaints on billing, how much cost can we take out? And that's a whole different skill set than designing an RF module on a meter.
and believe me, the utilities know the cost per call, or even the cost per minute that their customer service people are on the phone. They've got that down.
Yeah. Yeah. So I'm just going to jump here to another question that came up on the technical side for getting that information back. We've got a question about the value of backhauling AMR data via fiber versus PLC or 900 megahertz. And some of this is kind of pushing into our next session here, but I think it would be interesting to have your take on that for both Ross and Dave.
Dave, you want to take that first, or want me to take it?
I'll take it. Yeah, because I've been looking at it for a couple minutes. Yeah, there's different ways to backhaul data out of a meter, and it all depends on your business case at your particular utility. So, for example, fiber. Well, the case for using fiber is, does the city or the municipality have fiber in the ground, and do they use it for something else that they can piggyback on the system that's already in place? A perfect example of that would be the city of Chattanooga, Tennessee. They have fiber to everybody's home, and they actually sell cable TV subscriptions. Power line carriers been around for a long time, mostly in rural utilities. where you don't have any communication and the information sent through the power line. There was a company that had something called a turtle system. So the word turtle system tells you pretty much a lot about it. It was very, very slow. There were some companies that started some power line carrier experiments. The problem is always the transformers. You've got to jump the transformers. And I remember I was involved in some PLC in Cincinnati, Ohio with Synergy, which was the predecessor to Duke. 900 megahertz. That's an interesting one, and it's almost exactly the same as the new 5G cellular that's coming out. It's almost straight line communication. You've got to have a lot of receivers and transmitters, so hence you've got to have a network build out. So those are the differences, and it all depends on the business case for the individual utility.
Maybe I'll just add to that. In my estimation, there's two things that are critical that utilities have to decide, particularly when they're using RF communications. One is that are they going to use a licensed frequency band or unlicensed? Now the ERT is unlicensed. It's in the 902, 928 ISM band, which means you don't have to get. The good news is you don't have to get a license. The bad news is you have to be able to accept whatever that noise floor is. There are other technologies that are licensed as well, so you know what you got. Census has one of those. And the other thing you need to decide is: are you going to use a public network or a private network? Are you going to have your own network that you're going to own, operate, or are you going to use a public network? And Dave talked about 5G coming. I mean, one of the things when you're using particularly when you're using a public network, you have to be concerned about is what's the technological obsolescence. With technology moving as fast as it is, how long will we have 4G LTE around? How fast is 5G going to be here? How fast are the manufacturers going to get it into their devices? How fast is the network going to be deployed? And is it going to be do you need a forklift upgrade to do that upgrade, or is it a firmware upgrade you can do over there?
Yeah. I remember one instance where we did some AMR for a utility. We deployed, all of their C&I customers with a particular technology. It was the twice before predecessor to LTE, which is 3G. I remember after we got that technology installed, we were sitting in a meeting and we got a letter from the carrier saying we're phasing out support of that technology in the next 6 months. And it was a scramble to change technology on the hardware.
Yeah, and with all these technology options as well, and evaluating all that, especially with the business case side of it and deciding what to put in, the regulations for the particular utility also have an impact on that. And especially around this time here when we're talking about the introduction of AMR and bringing out all of this, it's now possible to get this data more often and more reliably. There was a lot of change in the industry around deregulation, customer choice. I mean, that's still going on in some areas too. Dave, can you talk about how that impacts meter reading, and maybe that ties in for a lot of people into this technology discussion?
Yeah, the transparency of all the data is really important with deregulation. The first state for electric in the U.S. that was deregulated was New Hampshire. So besides just having the utility as the only entity who owns the cash register, now all of a sudden, if you're a electric company or an ESCO, electric service company, you're using somebody else's cash register. So the idea of having transparency of the data or being able to shift the data from one place to another place. So let's say ABC Power Company can now bill somebody, and they're not the wires part of the business. So you've got to be able to share data. And along with that sharing data, customer privacy is a gigantic issue. I remember when that first hit, there was more talk about more of the privacy than there was the technology, because everybody is interested in maintaining that privacy. So as states unbundled, it was a big issue. They were even talking or moving down the path of having unregulated meter reading companies, and the utilities really didn't favor that too much.
Definitely. So we've talked about here, we've covered really from the, the 19th to the beginning of the 21st century and technology here and regulatory progress, because those are very interconnected. But really what we're doing is we're only setting the stage here for the next evolution. And some of these technical questions have touched on that. There's more to come in progress. And that's what we'll say for our next webinar here, our second session, part 2. We'll be talking about AMI and all the other kind of data options that come with it, and touching on some more of the regulatory side of it, how that impacts it, and all the data that's needed for these parties and the uses. So we hope to see you all September 15th, same time, 1 p.m. Eastern, for a part 2 of Evolution of the Smart Meter. And thank you all for joining today. We'll answer any questions that you might still have. And there should be an email address that if you've got some follow-up questions, feel free to email and we'll address those there too. Thanks, everyone.
Thanks.